Hi everyone, welcome back. This is our final video of the hydrocarbon series, and in this one we're going to be looking at isomers. So we've previously discussed the importance of knowing the definition of a homologous series back in video 1, and in this video I'm going to stress the importance of knowing the definition of isomers as well, because this is a really common question that crops up with SQA past papers. If you go back in the last 5 years or so, you'll find questions alluding to isomers quite often in the papers. So we need to know that definition of isomers quite well. So here we go. Isomers are molecules which have the same molecular formula but a different structural formula. So if we break that down, what that means is isomers are molecules, 2 or more, which have the same number of carbons and hydrogens but a different structure, so a different way of arranging these carbons and hydrogen atoms. So let's take a random molecular formula. Let's go for C3H6. And what I want you to do is you can pause the video. I'll give you a few seconds if you don't want to pause it. When you see C3H6, what comes to mind? Is it one molecule, more than one molecule? Could you name that molecule? Could you draw that molecule? What homologous series do these molecules belong to if you can think of more than one? So pause this video. Take a few seconds to think about what springs to mind when you see C3H6, and then we'll discuss it. Okay, so C3H6 can be represented of 2 molecules. First one is an alkene, propene. 3 carbon atoms in a row, double bond between the first and second carbon, and 6 hydrogens. Now we need to make sure that each carbon is making 4 bonds. So that carbon had 2 bonds made to the next neighbouring carbon, so it needs 2 hydrogens to make 4. 2 plus 2 is 4. This carbon here had 1, 2, 3 bonds to neighbouring carbons, so it needs another hydrogen to make that 4. And this carbon here only has 1 bond, so it needs 3 hydrogens. So we're going to call this propene, because it's got 3 carbons, prop, a double bond in that molecule, ene, and also I'm going to state that it's an alkene. Okay, so what else springs to mind? Well, I've not left myself a lot of space here, but I'm sure I can fit it in. We have cyclopropane, don't we? We've got a cycloalkane. And that is 3 carbon atoms, and as opposed to being arranged linearly in a straight line, they're arranged in a ring structure. If any of this stuff is sounding unfamiliar, please go back and watch any previous videos in this series. They will all be linked in the description. There's also a playlist on the channel if you want to look at alkenes or cycloalkanes. So 3 carbon atoms in a ring, we call that cyclopropane. Now, I'm quite tight for space here. I mean, we move this. There we go. And that is a cycloalkane. Okay, so from the one molecular formula, I'm able to deduce 2 molecules. One is an alkene, one is a cycloalkane. Think about the type of bonds that are unique to these molecules. Double bond is unique to alkenes. All single bonds is unique to cycloalkanes and alkanes. So we can describe this as being unsaturated because it contains that double bond, and we can describe the cyclopropane molecule as being saturated. So we can distinguish between 2 isomers by looking at their saturation, and that's an experiment we're going to come to later on in the video. In the meantime, let's have a go at another example. So let's put up C4H8 this time. So again, pause the video and see how many molecules you can draw or name based on the molecular formula C4H. So from the fact that I've split the whiteboard into 4 sections, you may be able to work out that there's 4 molecules that have the molecular formula C4H8 but have a different structural formula. So let's work our way through and see how many of them you got. First, let's go for our alkenes. Got 4 carbons this time, so it's going to be butene. 4 carbons in a row. We'll put a double bond between the first and the second carbon, and then fill out the hydrogens as appropriate. One, two, three, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So what would the name of this molecule be? Well, I said butene, however we have to specify the position of the double bond. The double bond is in the first position, so it's called but-1-ene. That may give you an idea of what the next molecule is going to be. That's going to be but-2-ene. Because if you move this double bond between the second and the third carbon, that is a different structure but the same molecular formula, which is the definition of isomers. So let's just draw that in. Same as what we have on the left hand side, just a different position for the double bond. And that will then move around the hydrogens a little bit as well, so we need to be careful here. That first carbon has 1 bond to the neighbouring carbon, so it's got 3 hydrogens. This carbon here has got 1, 2, 3 bonds to neighbouring carbons, so it needs 1 hydrogen. Same for this carbon here. And then it's a mirror image, we're going to have 3 carbons, 3 hydrogens, sorry, on this carbon here. But-2-ene. So we've got, there's 2 isomers there. Our next one, we're going to have 3 carbons in a row this time, double bond between the first and second carbon. So you may be thinking, well, this is propene. Where's that next carbon going to go? Look, we've got 4 carbons, we've only got 3 in a row, but remember, branches exist. So we can branch off that main propene chain with a methyl branch, and then fill out the hydrogens again as appropriate. So what we're left with now is 1, 2, 3, 4 carbons with 3 in our main chain and a branch coming off the second carbon, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So again, we're meeting that molecular formula with a different structural formula. What would that be called? That's quite a tricky one to get. Well done if you got that. Think about what that's called. It's got 3 carbons in its longest chain with a double bond in it, so that's propene. We've got a branch coming off the second carbon, and that branch is a methyl branch, so it's going to be called 2-methyl-propene. And because the double bond can only be in the first position, we don't have to state that in the name. So it's not called prop-1-ene, it's just called propene. And the last one, C4H8, CnH2n would be the general formula for that, which is also representative of the cycloalkanes. So we've got 4 carbons in a ring in a kind of square shape. So that is going to be called cyclobutane. Okay, so how do we test between these different molecules in a lab to determine what molecule we have in front of us? Let's say you had a test tube that said C4H8 on it. How would you know which one is which? So what you would test for is you would test for saturation using bromine water. So this is a really common laboratory test, and as I'm at home and I don't have the equipment in front of me, I'm going to link to a video in the description by Fuse Lab. They've done a fantastic video on the bromine test, and they'll be able to demonstrate that much more efficiently than I am able to at home. Okay, so I'm going to end the video here, but don't stop now. Please go to the description and watch that video from Fuse Lab now. Any questions, please let us know, guys. Thank you.